first experiment?
Kind of. I'm a little nervous. It's my first lab here, and all these safety rules are really confusing.
I know. When I took my first lab, I had the similar concerns, but once you understand the logic behind these rules, it'll be a lot clearer.
Don't you think, though, that a lot of these rules are a waste of time and will slow us down?
Don't worry about that. You can get seriously hurt, and that'll take more time from lab. I'll walk you through it.
All right, thanks.
Hey everyone! My name is Kayla and I'll be your TA for this quarter. Let's go on into the lab. All right everyone, just come on in the lab. Go ahead and put your backpacks and things in the cubicles, that way no one will trip over them. And grab your protective gear and come on to the front.
Nice glasses.
Oh, thanks. I got them from my research lab.
Mine are so dorky. I got mine from my dad's wood shop. I thought I would save a couple bucks.
I think we need splash goggles for the first part of this lab because we're going to be using concentrated sodium hydroxide solution, and that stuff is nasty if it gets into your eye.
Hey, are you guys ready to get started?
Almost. I just realized that my safety glasses don't give me enough protection, so I'll go get my goggles.
Okay. I'm afraid that yours aren't good either. See the vent holes? They won't protect you against a splash of liquid. You need chemical splash goggles that will give you indirect venting. Why don't you go ahead and grab another pair and come on back.
Okay.
Before we get started, I'll just point out the location of the safety equipment in the lab. Because you'll all be wearing your protective gear, you most likely won't need to use it, but it's important to know where everything is located. The eye wash is over there. Just pull the lever and water will automatically turn on. To turn it off, just pull the lever back to its original position and the water will stop flowing. The emergency shower is over there as well. Do you guys know how long you need to wash after exposure?
15 minutes.
Good job on reviewing the guidelines. If you get a spill on you, then quickly peel off your lab coat. And if your lab coat absorbed all the spill, then you're okay. If your clothes are contaminated, then you need to get into the shower and remove them under the running water.
No way, seriously? I'm not taking my shirt off. Someone will take pictures and put them on Facebook.
Don't be silly. It's not worth getting hurt over.
Yeah, you're right. Fine, I'll pretend I'm at the beach or something.
In case of a fire, we have an extinguisher and a fire blanket over there. Use the fire blanket to smother a fire, especially if it's on someone's clothing. Or you can also push that person into the emergency shower and turn it on.
Kayla, can you show us how to use a fire extinguisher? I've never actually used one before.
In the case of a lab fire, it would be better if you evacuated the lab and let us worry about it. The safety of people is much more important than the safety of the equipment or the lab. And we do have fire sprinklers. But in any case, it's important to know how to use a fire extinguisher in the few cases where it might be needed. First, you pull the pin that locks the mechanism. Then, stand 6 to 8 feet from the fire and aim the nozzle at the base of the fire. A common mistake is to aim at the flames, but you need to aim at the fuel. Squeeze the lever to release the chemicals and sweep it from side to side. An easy way to remember is the acronym PASS: pull, aim, squeeze, and sweep. Remember that if we need to evacuate the lab, then everybody needs to gather outside so that we can account for all of the students. And do you guys have any questions? All right. In this lab, we'll be working with various individual experiments, so make sure you read all of the bottles of the reagents carefully before you start using them, okay?
I always get confused about the order of addition. Is it water to acid or acid to water? I never understood it.
It's easy to remember if you know the reason. The problem is that the reaction between concentrated acid and water can be very exothermic. When water is added to the acid, the reaction is so vigorous that steam forms. The steam escapes and will cause the splashing of the concentrated acid. Adding acid into the water changes the situation. Since concentrated acid is denser than water, it sinks into the water and is immediately diluted.
Now I get it. Thanks for your help.
Hey Andrew, do we have any DMA left? Looks like we're just about out. I'll run to the stock room and get some more. Good morning, Professor Rios.
Hey Andrew, how's the lab going?
It's going pretty well. I'm just on my way right now to the stock room to go fill this reagent bottle.
Okay, I think you're missing something though. Let's go back in.
Okay.
Andrew, it's much safer if you transfer bottles using the secondary container, because it offers better protection in case the bottle falls and breaks.
Okay.
Oh, and don't forget to take off those gloves before you leave the lab.
Sounds good, Professor Rios.
Hey, Nathan.
Hey, Professor, how are you?
Good. Hey, why aren't you wearing your safety glasses?
Oh, sorry, they just fogged up for a second.
I know you didn't mean to do it on purpose, but what if your neighbor drops an Erlenmeyer and a piece of glass goes flying towards you? It's pretty dangerous. If you need to clean your safety glasses, just go outside, clean them, and come back in.
Sure.
Also, I noticed you're working too close to the edge of the hood. You know, this is not safe practice. Can I show you why?
Please.
All right. Look at the dry ice fog. You see how it behaves when the dish is close to the edge, and especially when the sash is wide open? Now, think about all the hazardous vapors that will escape into the lab. However, pushing it into the hood about 6 to 8 inches and bringing the sash down makes a big difference. Plus, it better protects you from both hazardous vapors and flying debris should something go wrong in the hood.
Thanks, Professor. That made a lot of sense.
Kate, this isn't very safe. Will you please step down?
I know I'm not supposed to fill anything up by reaching above my eye level.
That's true. You definitely don't want to take a risk by spilling a solution from above. But at the same time, you may fall from this chair. A better way of doing it would be to move the burette to the side of the bench and then move it down so that you could do your work at eye level. Then when you're done, you can move it back up and push it back.
Okay, that makes sense. Thanks, Kayla.
You're welcome.
Anjali, can I borrow your calculator? Anjali.
Anjali. Alex, you scared me.
Sorry, I was just wondering if I could borrow your calculator.
Yeah, sure, I'm not using it. Go ahead.
Thanks. I don't think we're supposed to be listening to earbuds in the lab.
That seems kind of silly to me. I mean, it's not like I'm working in the hood or anything.
Yeah, I know. It's just, it's kind of unsafe. Like, you can't hear what's going on around you and you might miss some things.
Yeah, you're right. All right, I'll stop listening to them from now on. Thanks for looking out for me.
Okay, I'll bring it back when I'm done.
Yeah, sure, take your time. No problem.
Thanks.
Finishing up for the day?
Yep, just getting rid of all my waste.
Alright, great. Do you know the proper way of taking off your gloves?
Yes. I learned pinch the first one, take it off, then use your thumb to take off the second.
Perfect. Okay, well, see you next lab period.
See you next time.
You know, that wasn't so bad. Thanks a lot for your help.
Yeah, no problem. Anytime.
I think it's all going to be all right.